Okay, Jocelyn and Nick, are you here?
Sorry.
Yeah. Okay. All right, so before the break, right, the identity we used so far was just reciprocal and quotient, okay? So starting from next one, we will be adding in more, okay? Reciprocal quotient and also square, right? Square identity. So the identity that we didn't use is the cosine double, sine double, right? So we might be using that in the next couple questions, right? You can already see in question C, we have cosine double, right? Cosine 2x. Question D, you have sine double, cosine double as well, right? So let's look at question C first. So do you think we should start with the left-hand side or the right-hand side? Philip, what do you think? Which side should we start?
Right-hand side.
Right-hand side, yeah. Right-hand side, more things, right? You have cotangent and tangent, you have fractions, right? More complicated. So this time we're gonna start with right-hand side. So based on our experience before, right? When we see cotangent, tangent, we can turn them into either sine or cosine, okay? As you do more questions, you will know better what to do, right? Okay, so I'll let you write out I'll let you go as far as you can, okay? And after you get stuck, or you got to the final answer, you can raise your hand, okay? So I just want to see how far you guys can go by yourself. So start with the right-hand side. Once you cannot do anything else, you can raise your hand, okay? I'm just gonna copy this one more time, okay? Cotangent, tangent, cotangent, plus tangent. So just go as far as you can. If you get stuck, then you raise your hand, okay? Okay, let's number the steps. Okay, so first step, second step. Okay, I don't know how many steps it will take. Okay, I'm just writing out the numbers. Okay, Lily, how many steps have you got so far?
2.
2. Okay, so you have the first line.
Yeah.
Okay, can you tell us what you have? What you put for your first line?
I don't know if it's right, but I wrote 1 over tangent x minus tangent x over 1 over tangent x plus tangent x.
Okay, it's not wrong. Okay, remember from the previous question, right? We could go to the tangent method, right? We could change to tangent and 1 over tangent, but we would prefer to have everything in terms of sine and cosine, right? You can compare the step we had before, right? The question B, right? If we use sine and cosine, the number of step is less, right? 1, 2, 3, 4. Right? If we do tangent 1 over tangent, you would have 1, 2, 3, 4, 5, 6, right? So try to change it to sine and cosine instead of using 1 over tangent. Okay.
Okay.
Yeah. Unless there's unless after you do that way and then got stuck, okay, nowhere to go, then you can come back and try the other way. Okay, Marcus, do you have the first step, Marcus?
I'm not sure if it's right though. I wrote cosine theta over sine theta. Minus
Over sine x.
okay, sine x, right, and then minus sine x over cosine x.
Mm-hmm.
And then on the bottom, it's the same thing. It's
Same,
top.
except,
Oh, it's plus.
yeah, okay. Okay, so it looks like everything the same, right? Except it's 1 minus 1 plus. So here comes a question, right? If we have the same thing, can we do something like this? Cross out, right? Cotangent, cotangent, tangent, tangent. Can we do that? Susan, can we do that?
No, because
Okay.
the signs are different.
Because the what?
The signs in the middle are different, and I
Yes,
think
yeah,
yeah.
very good. Okay, so if there's an add and subtract, if you want to cancel, you have to cancel the whole thing together, only if they are the same. Okay, the same reason we mentioned before. Okay, so it's like if you're not sure if we can cancel or not, think about this example, right? 1 minus 2 over 1 plus 2. Can I just cancel out everything? Right? It won't work like that. Okay, so remember, do not do any canceling now. Okay, if you already stopped writing, you can raise your hand and we go over the steps that you did. So we're gonna change everything to sine cosine, okay? So your first step will look like the one you see on the screen, okay? Everything in terms of sine cosine. If you do like 1 over tangent, it's fine, okay? Just that later you will might need to do more steps. Okay, so let's take a look at step 2. Okay, anyone wants to contribute? Step 2, what do you do after this?
You can multiply the top by the reciprocal of the bottom.
Multiply the top by the, what do you mean by that?
And just multiply the top by the bottom. Just solve. I don't know. I forgot my terms.
So you mean like cosine x
Over sine x minus sine x over cosine x.
and then times it by the flipping
Yeah,
like this?
yeah.
Okay, okay.
My grammar is not great.
Okay, yeah, I understand what you mean. Okay,
Okay.
so can we do that? The problem is, can we flip like that?
Oh, I didn't realize you. Oh, so you make it all into the same denominator?
Right, so we need to combine them first, okay? Because
Yeah.
right now the denominator has 2 fractions, so no flipping yet, okay?
Yeah, I did not realize that. Sorry.
It's okay, okay, very good try, right? Because it's very common, right? When we divide, you want to flip. So the problem here is the denominator has 2 fractions. If you want to do the multiplying reciprocal, right? If you want to flip, you need to add them up first. Okay, so your second step, let's use the green and red again, okay? The green for the top, red for the bottom. For both fraction on each side, your second step should be adding them up or subtracting them, okay? So this is a combined fractions. If you get multiple fractions, you should be combining them first. Okay, so that's our second step. So we'll combine each side together into one fraction. Okay, because now each side has 2 fractions. Combine together. Okay, so let's try again, okay? If you haven't done this, okay, you can do that right now. So please show me hands after you add and subtract each side, okay? Okay, please, please raise your hand after you add and subtract on each side. Okay, Caleb, what do you have in the green box, green brackets? Caleb, are you there?
Oh, hello.
Yeah,
Could you say that
what do
again?
you have in the green brackets?
Oh, I had cosine square x minus sine square x over cosine x sine x.
Okay, very good. Yeah, common denominator is sine and cosine.
Oh, same thing on the bottom, but with a plus instead of a minus.
Oh, okay, okay. So let's fill that in. Okay, cosine square plus sine square, and then sine cosine. Okay, does anyone have question about how we get to this point? Okay, basically we get a common denominator. Okay, so whatever that's missing, you need to times top and bottom by that, right? Common denominator. All right, step 3. Okay, if you finish step 3, can you raise your hand? What's your next step? All right, Lily, what do you do now?
I change the cosine squared x plus sine squared x to 1.
Okay. Anything else you also did?
No.
Okay, let's do that then. But at the same time, I'm gonna do, other than just changing that to 1, I'm going to make it reciprocal. Okay, so we can save a line. Okay, because it's not too complicated to not a big jump, right? I'm gonna write it on the side, but then flip the denominator. So when you flip it, right, it will become 1 at the bottom instead, and sine x cosine x. Is there anyone feel confused at this point? Let me know, okay, if I'm going too fast. You have to go as slow as we can, right? So everyone can follow. So we have an identity, okay? This is a square identity, makes it 1. Yeah?
Why is it what? Oh, wait. Oh, yeah, I understand now.
Yeah, okay. So there are two things that happen here. I flip the fraction. At the same time, I apply the square identity. Okay, so that's where the 1 comes from. Yeah, so you can see that sometimes a little bit risky, right? If I skip too much. So you want to make sure you go as slow as we can, but this is okay, okay? Just two things that happen, I will be able to follow, okay? All right, so what do we do now? Step 4. Okay, can you raise your hand again if you have your next step after this? What do we do? Okay, Eric, what should we do now?
Just take out the sine x, cosine x because you can cancel out, so it becomes cosine squared x minus sine squared x.
Okay, so let's reduce the fraction. Sine, cosine, numerator, denominator, they can cancel. Only if they are multiplying, okay? They can cancel the fractions. So you are left with cosine squared minus sine squared. Okay, and when you see, yeah, Eric?
Shouldn't the last one be cosine 2x?
Cosine 2x, where?
It says cotangent 2x.
Cotangent 2x.
Like after 4, step 4. Like
Oh,
the final.
oh yeah. My bad. Mhm. I don't know why I wrote cosine, cotangent. Yeah. Okay, and then this part, the final step here, right? This part is a double angle identity. If you remember from your quiz, cosine squared minus sine squared, it is equals to cosine double. Okay, so that connects nicely to your right, left hand side, right? So you're done. Okay, so this equals to the left hand side. Finished. Okay, so can you raise your hand after you roll this down? We're gonna look at another one, question D. Okay, Caleb, do you have any questions? Okay, instead of question D, okay, I want to skip, okay, question E first. Okay, because question E, because we have another one, right? Another number 4 we haven't talked about yet. Right, number 1, sine, change to sine or cosine. Number 2, use identity. Number 3, combine fraction, which we use a lot, right? When you see fraction, you need to know how to add and subtract them. We still have number 4, okay? Number 4 is needed for our next question here, okay? So please turn to page 73, okay? Question E here. So for this one, both sides has fractions, right? Should we pick the left-hand side or the right-hand side? Which side do you want to start? Chris, how about you pick? Which side do you want to start?
Left-hand side,
And why do you pick the left-hand side?
because it looks bigger.
Looks bigger, yeah, okay. Looks longer, yeah, okay. That's a good reason. Looks more complicated, right? Then you pick the left-hand side. Or there are more things you can do with it, right? If you look at the right-hand side, it's already very simple, right? So I don't know what to do with it, right? We cannot do any canceling, right? Or, yeah, so that's how you pick, right? So pick the side that has more stuff to work with. So left-hand side. Okay, I'm gonna copy one more time, okay? So what do you think? What's our step 1 that we can do? I don't know if it takes 4 steps, maybe more, okay? I'm just writing out. So is there anything we can do here? Any suggestion before I say anything? Yeah, Caleb?
Can we factor out the 2 from the numerator?
Okay, very good. They both have 2. Anything else we can factor as well?
Oh, and cosine.
Yes, very good. Okay, so you have a common factor. Okay, so let's write that down on the side. Factor. Okay, factor the GCF. The top, we have 2 cosine x as our common factor. Then what's left after you factor out? Claire?
1 plus cosine. Yeah, 1 plus cosine.
X, yeah, cosine X. Very good, okay? So you can check if you factor it right or not by multiply back in, right? You should get the previous line, okay? So we factor that out. So now if we look at our goal, right? Look at our goal, our right-hand side. We want to have 1 minus cosine. Here, at least we have 1 plus cosine, right? It's closer now, right? Except it's on the top instead of on the bottom. Also, it's opposite sign. Okay, so that's our step 1. We noticed that we could factor, right? So make sure you add it to your experience, right? Your memory. Sometimes if possible to factor, you factor it. Okay, what should we do now? Step 2. Anybody? Anything else you recognize? Anything special in the expression here? Any identities? Check your list, okay? If you don't have it in the head, right? Have your quiz beside you. Take a look. Anyone?
Jason,
Yeah, Daniel.
the denominator is a double angle, sine double, so it's 2 sine x and then cosine x.
Okay, let's do that, right? So denominator, we have identity to apply. Okay, let me use red. Okay, so that part becomes 1 plus cosine x. The top stay the same. The bottom part is 2 sine cosine. It comes from your double angle identity. Any questions? Okay, whenever there's identity to apply, you could try, right? See if it helps you. What can we do now? Step 3. Anyone?
You cancel out the 2 cosine x.
Cancel out the 2 cosine x. Very good. Okay, so anything that's multiplying, right? 2 and 2, it can cancel out. Remember the cosine here, you cannot cancel because the top cosine has a +1, okay? Don't cancel the wrong one. You can only cancel the one that are multiplying, okay? So this one, let me use a different color. Cosine x, cancel with the cosine x. Right, so we are left with just 1 plus cosine x. On the top, denominator is only sine x. Oh, we are getting much closer now, right? If you look at the right-hand side is upside down. And then the sign is opposite, right? Instead of 1 minus, we have 1 plus. Very close, 90% the same now, right? 90%. Okay, so after this is where the new thing comes in, okay? So let's go back up to here, page 71, okay? Number 4 is called multiply by conjugate. Okay, what that means is if you have A plus B times it by A minus B. Okay, I hope you remember this formula. Okay, what does it equal to? Do you remember, Evan? A plus B times A minus B. Evan, do you remember this, seen this before? Evan? Are you there, Evan?
Oh yeah, sorry. I don't.
You don't remember seeing this?
No, I've seen it before. I just don't remember.
Then can you help me expand this? Do the FOIL.
Oh yeah, I can.
Okay, and tell me what you get.
Is it a squared minus b squared?
That's right, okay. A squared minus B squared, all right? So the two brackets, if they are opposite sign, right? A plus B, A minus B, these two, they are called conjugate. Okay, so you can say A plus B is the conjugate of A minus B. Okay, A minus B is the conjugate of A plus B. Okay, it's like twins. Okay, so A plus B is the twin brother of A minus B. All right, look a little bit different, but they are together. Okay, conjugates. So when we multiply the conjugates together, then you can create squares. Difference of square becomes A squared minus B squared. All right, so that's the special part about conjugate. Okay, we're gonna use that here because we have 1 plus cosine x, right? And we want to have 1 minus cosine x at the bottom. Okay, so your next step is to multiply with a conjugate. So multiply 1 minus cosine x over 1 minus cosine x. So top and bottom multiply by the same thing, okay? Because you have 1 plus, so you multiply with a 1 minus. If you have a 1 minus, you will multiply with a 1 plus, okay? It depends. So this is called multiply by conjugate. Okay. So when we do that, that creates the 1 minus cosine x at the bottom, and that's our goal, right? If you look at the right-hand side, that's where we want to get to. So it looks like we need step 5, right? Okay, so number 5, the numerator, okay, the denominator, we'll keep it there, okay? We don't want to expand it because we want to still keep the 1 minus cosine x, okay? Do not multiply in the sine x. For the numerator, we have a conjugate. 1 plus cosine times 1 minus cosine. So if you apply the formula, right, so please write down what it becomes after you multiply the numerator together. Okay, raise your hand if you have the numerator. A plus B times A minus B. Here is 1 plus cosine times 1 minus cosine. Okay, Chris, what do you have? Numerator.
1 minus cosine x squared.
Yeah, 1 minus cosine x squared. Okay, don't forget the x. Okay, so that's using the conjugate formula, right? Or you call that difference of squares. Any questions so far? We're getting closer, right? Because now you have the 1 minus cosine in the bottom, right? Anyone want to help us out? Like, what do we do next? You still have extra sine x in the denominator. So somehow it should go away, right? But we need to show the steps. How do we get there? Anybody has a suggestion what to do here? Any identities we could use? Yeah, Eric?
It becomes sine squared x because 1 minus or sine squared x plus cosine squared x equals 1. And then we can just cancel it out into sine x over 1 minus cosine x, which gives us the left hand or right hand side.
Okay, let's write it down slowly on the side, okay? Remember this one was a square identity, square. So left hand side and right hand side, they equal each other, but you can move them around, okay? If you remember from the notes before, I think we wrote them down here, right? On your chart here. This one, okay? Sine squared will be 1 minus cosine squared. You can move the cosine squared to the other side. Or you can move the sine squared to the other side, right? They are all equivalent. Okay, so we are using this one here. It all came from the square identity. Okay, 1 minus cosine squared. So right here, right? We're using that there. Okay, so 1 minus cosine squared will now become sine squared. Okay, can you raise your hand if you understand how we get to this point? Okay, Caleb, Evan, Jocelyn, and Marcus, do you have any questions? How we changed the numerator? Jocelyn, do you have any questions? Okay, so once you get here, that's our final step here. Okay, sine x can cancel out with the square. So you have to write your conclusion, right? So you end up with sine x over 1 minus cosine x, which is the right hand side. Okay, so two main steps here, okay? Two key steps. One is the multiply conjugate. One is using the modified square identity, okay? So this is a very important question, right? You will have a couple questions that needs conjugate in your homework as well, all right? So I guess we are right on time, right? I'm still missing homework from Claire, okay? So the rest of you, I'll see you next week unless you have questions, okay? And have a good weekend.
Thank you, Jason. Bye.
Bye.
Thank you.
Thank you, Jason. Bye-bye.
Bye. Okay, so Claire, do you need any help with the homework?
Oh no, I haven't started because I was really busy this week and last week.
Oh, so
Yeah.
what's the plan?
I could probably head in this week, but I don't know when this week because I'm also pretty busy this week.
Oh, okay. So then you will have two homework to hand in though, okay?
Yeah, I could do
Yeah.
this homework seems easier, so I think I can hand this in on time.
Okay. Yeah. All right. So I will see you next week then. All right. So please remember. All right.
Okay, see you.
Bye bye.
Bye.
Bye bye.